So we want to basically take this and solve for x. So the first thing I'm going to do is I'm going to divide both sides by 2. 2 divided by 2 is 1. 1 times 5 to the x is this. And then 14 divided by 2 is 7. Now remember, if I say b to the n equals m, that's the same as the log base of m equals n. So I could say the log base b, which is 5, raised to the m, which is 7, is equal to x. But the problem is that on a graphing calculator like this one, I don't have log base 5. So what we want to do is we've got to remember that log, there's that one property where I could rewrite this as log base 7. This is called a base conversion over log base 5. In other words, log base 5, log base 5 of 7 is equal to log base 10 of 7 over log base 5. And your calculator has a thing called the natural log, which is log base e, but the natural log of 7 over the natural log of 5. And this is what we call a base conversion. And so I'm going to use this base conversion property on the calculator because that'll give me the answer. In other words, if I were to type in on my graphing calculator, if Mr. Adams goes to his website and I use one of these fancy calculators, it's going to let me plug in some numbers, log base 5 of 7. But you're not going to be able to use this on the SAT. In other words, you can't bring your laptop into the SAT. So if I hit go on this calculator will calculate it for sure. But if you have just the standard calculator, it won't. So anyways, it says it's about 1.2, right? So this is approximately 1.2, right? Roughly. Now let's see what this equals. So if I just take up a regular standard calculator and I could use log of 7 divided by the log of 5, that's the conversion, and I hit enter, I get that 1.209, right? And then if I hit the natural log of 7 divided by the natural log of 5, I'll get that same number, okay? But in the actual question on your test, it's just asking you how can you use the conversion ratio to get that, all right?